All right, should I go ahead and get started? Hi, everybody, and welcome. We're going to talk about, let's get rid of that little thing. I guess we're just going to keep it, because I can't get my mouse over there. So that's funny. No? Oh, now I have a mouse, okay. All right. Technology is hard, right? So if it was easy, we wouldn't have our jobs for also jobs. I sit down, yes. So hi everyone, welcome, thanks for coming. We're going to talk about OpenTelemetry. My name is Josh. I love to talk about open source a lot. We'll start on that back and I'll just keep going. I work at a company called Attendees. We do open source hosting and support for ClickHouse, which is a massively scalable analytics database. It's something that you might use to, for example, store distributed traces, which is one of the things that we're going to talk about more in this talk. But besides that, we're not looking about the databases. I'm going to talk about the telemetry sequence, right? The stuff that we're putting in the database. I'll put a ton of out there. So that'll take those. Especially all right, so the question I really want you to think about while I'm up here talking for the next hour is this. How do we debug our applications? Like this, right? So that was a pretty short talk. Thank you all for coming. No, if we're in this room, right, we all laughed at that because we know, actually, that this is the easy part, right? Once you get here, your job is almost done. You've done a lot of debugging and investigative work to get to this point that you are now Googling or, in 2025, probably asking ChatGPT, right, what does this specific error message mean? Because none of us have all of that crap memorized. We would never be expected to. So this is the easy part. How do we get to this point, right? How do we get our mean time to Google low? So that's what we're going to be talking about. And the buzzword of this, of course, is observability, right? And every vendor, every marketing team has their definition of observability, and they're all very complex and flowery. But to me, the key word in all of these definitions is understanding, right? There's visibility and understanding. Can you see what's happening? And then seeing what's happening, can you make sense of it? And that's really the ultimate goal. And everything else is just a means to achieve this. And also, right, from its output to known, meaning we're not going to modify the system necessarily in order to get new outputs out that help us diagnose whatever the problem is. We should already have enough information coming out of the system that we can understand it. That's not always true. Sometimes we are going to have to modify the outputs to test a hypothesis or something like that, but this is kind of it. So just to kind of step back from this at a very high level and into another field, right? We think about an airplane cockpit. An airplane is kind of like a modern microservices architecture, right? Like you've got a lot of disparate systems that are interconnected in various ways, maybe more interconnected than we want to believe, right? It's not like a neat little hexagonal architecture. And so we have all these different systems that are behaving in various ways and affecting one another and creating pressures on one another. And we have all of these gauges and dials, right, to see what's happening with those systems. And then we have all of these buttons and levers to put inputs back into those systems and to make them behave in the optimal way that gets the airplane to where we're going, to where we want it. This is a fairly old cockpit though, right? Like this is, I think, a DC something or other from the 70s, or maybe even older. So if we take a look at a modern cockpit, here's a 787, this is a lovely airplane. We'll notice that things have changed, right? A lot of those, well, first of all, I will mention there's still a lot of buttons, right? This is for a really good reason. Boeing tried to make a cockpit that was entirely touch screens. You can't really use a touch screen in turbulence. So that was a bad idea. Pilots really need buttons. I still prefer physical buttons in my car. Buttons are good. But the information, right? The information coming into the pilots, all of those gauges are gone. And they've been replaced with these 4 multi-purpose screens. And the thing that these screens do is provide context, right? No longer does the pilot have to stare at a whole wall of gauges and hope that they're looking at the right one. You can bring the context into whatever goal or task you're trying to achieve in that moment onto the screen right in front of you. This, to me, is a perfect encapsulation of what we're trying to do with observability. We're trying to take this wealth of data, right? Because we've captured pretty much everything, right? And shipped it off somewhere and paid a lot of money to store it on a hard drive. We want to make use of it. And the way that we make use of it is by contextually bringing it up in the right moment. So how do we do that? Right? That sounds great, but like how do we actually do that? Is it with like tags and filters and full text search and Splunk and all of these things? Well, maybe. But I think there are some other ways to do it too. Now, if we kind of step back into like the observability, like market space zeitgeist, right? There's this conversation going on between Charity Majors from Honeycomb, some other members of the community about like what they're calling observability 2.0 or maybe 3.0. I don't know. They're trying to put numbers on it. But the point that I really like from all of this discussion is this one. And it's really that like we've had these, raise your hand if you've heard of the metrics, logs, and traces as the 3 pillars. Okay, so some background, right? Like going back in monitoring and observability, we had metrics, logs, and traces, and you can find a million blog posts from vendors online trying to get their SEO up, talking about the 3 pillars of observability, right? It's metrics, logs, and traces. And yes, they're right. Those are the 3 fundamental data types that most observability systems deal with, right? Like you're saying that for a fauna stack, you're going to have Loki for your logs, Prometheus for your metrics, or maybe Tempo, and then maybe Numerator for your traces, right? So all these things, these really are the 3 pillars. But if we think about what a distributed trace is, it's actually kind of just a really, really good structured log, right? And then we think, okay, well, we just have really good structured logs, and then things that we can count. That's it. Those are the 2 things we actually just. So we look at a really like a typical log, right? And I've destructured this, but in your actual systems, this should be JSON or something structured, right? But just so that we can read it all quickly, that's very typical request log. We've all seen this multiple times a day throughout our careers, right? It has a lot of information in it, actually, if we can start to aggregate these and count them. Actually, it was missing something really important. It was missing duration. So we'll add duration, and now we start to have some performance metrics and latency and things like that. We can actually build this whole dashboard just from request log messages that look like the previous slide. So we can get the number of requests coming into the system, the percentage of them that had an error, and the average latency. So that's your RED metrics, request error restoration, or the golden signals, as Google likes to call them, right? If you read the Google SRE handbook. So that's it. We got all of our golden signals. The one other thing that Google would add to this is like the saturation of the resources on host, like the CPU saturation and the memory saturation. And that's where metrics come, right? So if we can build this from logs, even though these are all metrics derived from counting things in logs, and then just the CPU utilization, memory utilization, that comes in as a metric. Then we have our complete Google golden signals. This is cool if you have it like for your public endpoints, but you also want this for every single service in your system. All of a sudden you start to understand the health of your entire system by having this information for each endpoint. Okay, that's pretty good. We're starting to like kind of get a picture of like how we can like see the really big picture and start to identify errors, right? Or like, is there a problem that we need to investigate further? But there's still some missing information, right? And a big thing that's been happening in the last few years is we've focused on being more user-centric in our ways of thinking, right? We've kind of evolved in all of our various fields, whether it's security or observability, to think more about like think about things from the end user's point of view rather than from our point of view. So back in 2016, I was working at a startup, and we had this brilliant idea. We were the only people ever on the face of the earth that did this, right? To put the request ID into our request logs, but not just on the API endpoints, right? We would then propagate this request ID to all of the log messages for every downstream service in our poorly designed microservices architecture. This was really cool because it meant that if something went wrong, we could really quickly, with one simple query, pull all of the log messages for everything that might have been a factor. But we're still missing some information. We're missing the chain of events, right? This lets us get a bag of logs that are relevant, but it doesn't have any relationship between them. So we can make it even better. And all we really have to do is this, right? We just do the parent ID. So we've got trace and span, right? Trace would be the overall request that was kicked off by a user hitting something on the public API. And then each span, typically you'd have a span for each downstream service that handles any portion of that request via HTTP. You might also have more internal spans if you have interesting functions and things that are happening, right? But really all it is just a tree graph, right? So we have a trace and then a branching tree of spans off of it. And now our logs are traces. I went one way. And we can do this with them. We can visualize them just like the Chrome developer tools, like waterfall graph that we get for our front end, except now we're doing it for our entire back end, all of our databases, all of our caches, all of that stuff. So this is what it looks like to view a single distributed trace. And I think the value of this is immediately apparent, right? Like this just is a great way to visualize a single request. But I also think that there's a lot more value here than what is immediately apparent, because if we start to aggregate this information, then we really can start to understand how our system works based on real traffic, not based on like some outdated documentation or bugging senior architect on Slack, right? All right, so I think traces are awesome, but it is important to keep in mind, observability is not any one signal, right? It's not distributed tracing, it's not any of these. It's the goal, right? It's the goal of understanding. And each one of these does serve some purpose in that, right? Metrics, whether you aggregate them at the source, which is how most tools do it now, like Prometheus, or you counted them after the fact with that micromining that you do based on that dashboard you saw, right? Metrics are really good at answering the question, is there something wrong? Is there smoke? Because they're numbers, right? So we can just say, does the numbers fall within the expected range or not? It's a binary question. Traces, their fundamental characteristic is that they are scoped to a single user request. So that gives us that user-centric point of view to go through our entire distributed system and identify where is the actual problem. And then at the end of the day, right, logs still really, really matter, because they're verbose. That's where we can put all of the information about what the actual problem was, that we're then going to go type into Google or ChatGPT so that we can solve the problem. So we need all. But distributed tracing, I think, is kind of the killer app, right? Like, I think it's really, really key to why we're now calling this observability instead of monitoring. It lets us understand the complete request flows through our entire system. It lets us create a real-time map of the system topology and what depends on what, and what calls what talks to what. We can count things in traces, right? We can drive things from the richness of the trace metadata. And traces, unlike metrics, are not really, most trace data stores are not limited in cardinality the way that, say, Prometheus is, right? So cardinality meaning like you only have 1,000 unique values or so across a dimension in Prometheus before things start to slow down. Thousands is the cardinality that we're dealing with in these metric systems, right? In trace systems, we can have cardinalities reaching into the millions, and the system doesn't care. It will still handle that if it's designed well. So we can put whatever kind of metadata we want on our traces, and then maybe that will be useful for some analysis after the fact, but we don't really need to think about this too much in advance. We don't need to think about the questions we're going to ask about our system in advance when we're building the system. We can just put all the data in there and then ask the questions later. And logs, like we just talked about how useful logs are, they're a lot more useful when they're really easy to find because they're attached to a trace span. So that it just makes the logs even better when you have tracing. And this is why we have OpenTelemetry, right? So before OpenTelemetry, it was really easy to do logging in a sort of a standardized way because a log is just a text string, right? Or maybe a JSON log. There's nothing that needs to be standardized about that to make it interoperable across all of your systems. Same thing with metrics. It's, a Prometheus metric is basically just also a string. It's a bunch of labels and then a value at the end. So these things they already had good enough standards that were universally applicable to our systems. But for distributed tracing, I skipped this when I was telling the story earlier, right, about putting that request ID in the in all of the downstream services. That's actually really hard to do, right? That's actually not an easy task. It was hard for us working as a small team of 5 developers with single language, right, very homogeneous ecosystem that we had complete control over, and it was still a challenge. But then you talk about taking this idea to an organization with 4,000 developers and every technology under the sun, right, and a bunch of third-party technologies that you can't modify and don't have complete control over. This starts to become a really, really big challenge. And that's where observability vendors stepped up, right? So you have Datadog, Dynatrace, New Relic, all of these vendors that give you these tools to do this, but those tools require you to put their proprietary code inside your code artifacts, right? And that to me is really why OpenTelemetry exists, is because we needed to have this code that spoke this universal standard across every programming language and every tech stack, and it needed to be vendor neutral. Because if I'm making Phoenix for Elixir or Express for Node.js, right? I'm not going to go embed Datadog libraries in my open source project. But I might embed open source libraries in my open source project. And then all of a sudden, anybody using that project can just turn on their telemetry, and they have it in this open standard format. That's why OpenTelemetry needed to exist. So what actually is it? Let's get into that a little bit. So most of you are going to interact with it through the SDKs. So this is where I'm going to start, with the SDKs. These are the parts that do go in your code that replace those vendor libraries, right, that we didn't want. We have SDKs for 11 different programming languages. They're in various phases of stability. But this isn't really changing a lot, right? Like right now, some of these things that are marked as development or beta, it's just an abundance of caution. They're perfectly fine to use. Things have definitely stabilized a lot in the empirical system within the last year. So these are all the different programming languages that you can use it with, but that's not the whole story, right? OpenTelemetry is a lot more than just the SDKs. It is specifications. These are really important. We just talked about kind of why we needed this open and common universal standard. It's the actual libraries and tools like the SDKs that we were just talking about. And then it's the community that creates it, right? So specifications, W3C trace context. This is the most important one. This is how that trace ID and that span ID gets propagated from service to service. It's a very simple specification. Basically, you just put it in your HTTP headers or HTTP headers, right? So you put that in your HTTP headers, you put in the span ID and the trace ID, and each downstream service takes that, says, oh, okay, I'm going to make traces that have spans that have that span ID as the parent. And then I will put my span ID in any outgoing HTTP calls that I'm making to further downstream services. So each service emits its own telemetry based on the context provided by the service that called it, and that context comes via the W3C trace context. Right, the language APIs, so this is a specification for the functions that you can actually call from within a specific language to create telemetry. It's actually, the libraries that provide these APIs come with a no-op implementation, so this is how you can actually include them in your library that other people will use. And it doesn't actually have to do anything, it can just provide the no-op function and work. And then when that user installs their own configuration, it replaces the no-op implementation with the one that they want. And then we have OTLP. So this is the wire protocol that is actually used to transmit telemetry. It can go over HTTP or gRPC, right? There are protobufs for it. This is my favorite part of OpenTelemetry because this is what makes it possible for anything to talk to anything else, right? Like, say you don't like the SDKs. They're kind of cumbersome. I'm going to talk about them in a little bit, right? But say you don't like them. Make your own. As long as it talks OTLP, it can talk to anything else in the OpenTelemetry ecosystem. You can replace any piece, right? And OTLP just becomes this lingua franca between all of the pieces. Kind of like functional programming, right? Like if you just design your data structure well, you can have a million different functions operating on it on that same data structure. And it's the semantic conventions. Naming things is one of the hardest things that we do. So the semantic conventions gives us a universal way to name things. Now we don't have to worry about, oh, that team called it HTTP recs, and that team called it requests. Or maybe they just use an underscore versus a dash, right? Like that kind of thing throws off all of these tag and label-based systems that we have. So OpenTelemetry gives us semantic conventions, and it's like, look, just follow the semantic conventions. They're very well defined for most of the things we care about, like databases, message queues, requests, right? If they're not well defined, they're open standards that you can contribute to. So submit a pull request and say, hey, I wanted to add this metadata about my app, and I didn't find the correct keys for it, so I submitted some to the community. So naming things consistently makes all of this a lot easier. It's the language SDK. So this is what actually provides the implementation inside your services, right? So you would install the language SDK. You would provide it with some plugins that basically tell it what you want to do with the telemetry generated by your application. The instrumentation libraries. These basically map from the libraries that you are using to the language APIs. So like before I said I was using Express. Say Express didn't come with some built-in instrumentation. It doesn't. You can install the Express auto instrumentation library, and it knows how to observe Express running in the same process, and create telemetry for it by calling to the language APIs, which then call the language SDKs, which then gets to your service. There will be visuals for all of this, don't worry. The collector, so this is another really big piece of the project. The OpenTelemetry collector is it's a binary written in Go. It's highly extensible. We're going to talk about it a lot more, but basically it replaces your vendor node agent, and it also acts as a proxy for your storage backend and collects and gathers things. That's why it's called the collector. One of the things that would be nice about the OpenTelemetry project was if it didn't just take generic words like collector and try to make it like the collector TM, because then it gets really confusing when we're talking about this stuff. So that's just the fun of building a new. And then there's the Kubernetes operator. This is just a convenient tool that makes it really, really easy to deploy the collector in a Kubernetes cluster. And it also can do auto instrumentation. So say you have in Python, Java, JavaScript, Ruby, and kind of PHP. It can auto instrument your containers. So you just deploy a pod to Kubernetes that doesn't have any instrumentation in it at all, but it matches some metadata that you gave to the operator, and the operator will mutate that pod and add instrumentation. There's a bunch of different mechanisms for how that happens. They give a whole other talk about that. It's on YouTube if you want to go check it out. And then it's the community, right? OpenTelemetry is the second largest project under the CNCF, Kubernetes being the largest, of course. I think it kind of makes sense that OpenTelemetry is such a large project, but by large I mean by number of contributors, to be clear, because it's so pervasive, right? It touches so many aspects of what all of us do. It makes sense that all of us would be feeding back into that and contributing. It's events and meetups. Thanks for coming. This is awesome. And on Slack and on GitHub, it's the OpenTelemetry end user working group, and then all of the other various working groups and special interest groups. You Google OpenTelemetry community calendar, you'll find a list of when all of them meet. You can reach out to organizers and maintainers on Slack and be like, hey, I have this issue, and they'll tell you when you should come to the meeting and bring it up. So this is a great way to get involved. I especially like the interviews that the end user working group does on like actual companies that are using OpenTelemetry at scale. Some of them are solid. Okay, so let's talk about the stack a little bit, right? This is kind of the same stack that we would have for like any observability solution, open source, OpenTelemetry or not, like a vendor service. A vendor one would look exactly like this right here. We have our service, we have some SDKs that go in our service and send data to a thing running on a node probably, like a vendor agent or the OpenTelemetry collector, and then all of that stuff gets shipped off somewhere to be centrally stored and analyzed. Very importantly, the OpenTelemetry project itself does not include anything for this yellow box, right? There are tons of open source options, and I'm going to talk about some of them, but none of them are part of the OpenTelemetry project or like officially sanctioned. The OpenTelemetry project is largely contributed to by observability vendors who would very much like to sell you something for this part, and with good reason, right? But if we make it a little bit more specific to OpenTelemetry, here's what it starts to look like. Can everybody read this? I'm going to zoom in on the individual sections. Is it horrible, or should I just wait till I get to the sections? All right. We're going to wait till we get to the sections. But we got some stuff in our code on our node and somewhere else. I don't know if somewhere else is already shown. The API and SDK both go in our code. They're extensible. They have processors and exporters. You don't need to think about this too much. There's a batch processor that you will probably use to save network. And the default exporter is the OTLP one, which you should absolutely be using. Do not use any vendor exporters. Do not let a vendor tell you that you should use their exporter. That was wrong 3 years ago. Instrumentation libraries. These are, right, we talked about that. Those are the things that like, translate from like your libraries to OpenTelemetry. And then manual instrumentation. So this is the part where you actually go in and tell OpenTelemetry about the things that the instrumentation libraries didn't know about, like orders, regions, business units, right? Like anything that you care about that maybe isn't like built into the libraries that you're using as is. Then we have the OpenTelemetry collector, right? This is running on our node. Asterisk, because sometimes you might also run, like you're gonna run it as a data set on your Kubernetes cluster environment. You might also run a deployment that acts as kind of like the gateway or the proxy, gathering telemetry from the daemon set and then forwarding it, because a lot of backends don't like to just have like 1,000 open connections. receivers, processors, and exporters. So the collector is even more extensible than the SDKs. It gives us these 3 types of plugins. We're going to talk about them. There's actually 4 types of plugins. We'll talk about that in a moment. But basically, we can configure the collector with all of these various extensions. The collector is what gathers our host metrics and logs, right? So if we have anything that's not specific to a specific process that has the SDK installed, then the collector is going to have receivers that are capable of gathering that. Because the file log receiver, which is used on Kubernetes node to grab the logs directly from Kubernetes. And then it's the automatic instrumentation, right? We talked about the Kubernetes operator and how that works. You can also do automatic instrumentation in those same languages by setting environment variables, or in some cases by installing like one package that then takes care of the rest, if you do have the ability to modify the package or the binary. And then, right, so we gotta put it all somewhere else so that we can actually do useful things with this. Otherwise, we're just paying for expensive storage. All right, is this easy to read, hopefully?
Yeah.
Yeah, all right, great. So, in your code, right, this is I'm just talking about this all twice, but just to give you like kind of the clear mental picture model of how it all fits together, right? If we have our service is the whole box, the purple box, and then like this other little purple box would be like the manual OpenTelemetry API call that we kind of like adding metadata to spans or creating internal spans for like particularly expensive functions, things like that. Then all the loop stuff comes from the OpenTelemetry project, and those are just plugins that we install or extensions that we install, and I'll show what that looks like in Node.js in a moment. So yeah, this is kind of like how it fits together in each one of your services. And then it gets shipped off to the OpenTelemetry. So the OpenTelemetry collector, as we mentioned, has receivers, processors, and exporters. Receivers kind of do what it says on the tin, right? Like they receive telemetry data. They can do that by exposing the negative to a GRP standpoint. They can also do it in a like pull-based mechanism, like a Prometheus scraper. And that's actually one of the receivers is basically a Prometheus scraper. So you can just replace your Prometheus agents with the OpenTelemetry Prometheus receiver, and then any of your Prometheus exporters can be read by that. I would argue that, right, if you shouldn't be pre-aggregating metrics, but this can give you a potential on-ramp to keep using the things that you already have in place. Processors, there's some really interesting ones, right? Like there's the OpenTelemetry transformation language, which has a processor that allows you to do things like transform some of the metadata. There's a processor that allows you to like just count things, right? And then there's exporters, right? So the exporters, there's missing arrows here, but there should be like a big arrow coming in here and a big arrow coming out here, because the connector one is not the most important one. So the exporters send the data to your backend or backends, right? Like most organizations have more than one observability tool that they're using. Maybe you merged with another team and they've been using their favorite tool and you've been using your favorite tool, right? So one of the uses that OpenTelemetry enables that was not possible before, because we have all of this vendor neutral stuff on the source side, we can actually just multicast it to multiple destinations. And since all of the vendors have bought into on this and they all speak OpenTelemetry to varying degrees, right? You can just share this, collect the telemetry data once, and then send it to all the different backends that care about it. Whether you want to do this all the time because different teams like different tools, or you want to do it just for a little while to kind of do a bake-off and compare and contrast different things, right? But this is really, really cool. It wasn't possible with vendor-based instrumentation. You basically have to stand up 2 different copies of the application to send it to 2 different backends. Because that's another thing I'll talk about in a moment, but like, do not instrument applications with 2 different technologies. Don't use OpenTelemetry and a vendor, or like 2 different vendors. That's a bad thing. Oh, and then the connectors. Connectors are really, really cool, but you mostly won't use them. But the one really, really cool one is the span metrics connector, right? So what connectors do is they basically connect the end of one telemetry pipeline. And by the way, each one of these pipelines is on a single signal. So it'd be 4 metrics, or 4 traces, or 4 logs. So the span metrics connector connects to the end of the exporter of your span pipeline, and then feeds into the receiver at the beginning of your metrics pipeline. And it basically just does those REE metrics, right? It counts the number of requests that are coming through your spans, so that you don't have to spend compute, aggregating that in your services, and so you don't have to decide in advance, right, like what dimensions and things. It can all just be done after the fact in your agent, which is really cool. You can add up other things like how many order totals, right? Tons of cool stuff you can do with connectors. But basically, they're for translating stuff that was coming out of one signal pipeline into inputs in the other signal. If you want to read more about OpenTelemetry Collector, there's a QR code for a blog post that I wrote about it. That goes into a little bit more detail about what we're talking about right now. But basically, right, its uses are to gather and forward the telemetry to the backend. We can use it to apply filtering, sampling, and batching rules. We can translate between any compatible sources and destinations. So that's kind of that multicast use case that I was talking about. And we're using it to gather our node and cluster level telemetry. It's kind of like a Swiss Army knife, right? So because it has all these various receivers, there are more than 90, and it has all these exporters, you can use it to translate between pretty much anything, right? Anything on the receiver side, it's then going to be this generic OTLP, trace metric or log in the middle, and then you can export it to any of the ones that support that signal. These are just some of the ones that I have used, but there are tons, right? There are tons of community supported ones, and then it's also possible to make your own if you like messing around with Go. So how do we actually use this thing? Well, it's pretty straightforward, actually. It seems scary, but it's not. Just instrument your application, right? We showed that you need those 3 pieces. Then you need to add some of your context, collect and process the data, and forward it to the backend. So instrumenting. This is from the OpenTelemetry demo project. This is in Node.js. These are all the includes, right? This file actually is called instrumentation.js, and there's like 12 more lines that are relevant, and those 12 lines basically just set up the Node.js auto instrumentation libraries that we included here on line 2 and 3. So that's it. That's the whole instrumentation for the entire API layer of this Node.js application. I think it provides like a dozen or so endpoints. So that's cool. I wish this was like 2 includes instead of 5, but that just goes to show you, right, like OpenTelemetry is very much a bag of Lego blocks, and you kind of, like, no one gives you the instructions. You're gonna have to put them together yourself in the way that works best for you. It's very flexible, very powerful. Sometimes you might step on a short bar. Then we need to add additional manual instrumentation and context. So this is really straightforward, right? Basically, we just need to get that context variable, which depending on the programming language that you're working with, there might be a global, there might be a function that you call to get it. Right? You just get that context variable, and it's going to have the currently active span, and then you can add metadata to that span, or you can create subspans. You can also create metrics, right? Like other types of instruments like metrics gauges, and you can make logs. But distributed traces is fast. Just do this. Just put everything in here as an attribute, and then make sure that your backend can handle that. Is what I would do. The collector is configurable with YAML. Who loves YAML? Come on. Sorry?
It's better than JSON.
Yeah, I'll take that. Thank you. It's horrible, but it's the least horrible thing we have. This is what the collector configuration looks like, right? So basically for each one of those each one of those plugin types then has a key for the plugins that you're using, and then each one of those is going to have various configurations. For a receiver, it's going to be things, right, like what do we actually want to scrape if we're using a Prometheus receiver. If it's just like the generic OTLP receiver, there's really nothing to configure. You're just saying like, hey, if someone sends you stuff on port 4318, you should take it and treat it as OTLP. So there's not a lot to configure there. And then on the exporters, this is pretty much what every exporter configuration looks like. You're going to have the endpoint and like just a few keys to configure, like authentication, things like that. So very, very straightforward, right? Specifically, this is for the TechCast exporter, which I'm a big fan of TechCast. That's the database that my company supports. And it has this async insert feature, or think about what that does. Pretty straightforward. It doesn't wait around for the data to be guaranteed, which with telemetry data probably is okay for most use cases. Okay, we're done. Everything's awesome, right? That was easy.
Yeah.
Kind of. So we don't want to run too fast, right? There's some pitfalls and warnings. I'm going to warn you about them now so that you will not fall flat on your face like this poor little girl. So we talked about this one a little bit, right? There's a lot of libraries and tools to stitch together. There's a lot of new vocabulary to learn when you're wading into the OpenTelemetry ecosystem but don't let it scare you. It's just vocabulary. Like, at the end of the day, it's going to map back to concepts that you already know very well. You just have different ones. The specifications are semi-stable. This was worse like 2 years ago, and even last year there was a major upheaval where like the HTTP specifications got changed, which then means like every vendor that's great. Like I said, like if it speaks OTLP, it speaks OTLP. Great, don't change OTLP because then a lot of stuff has to change, right? They're pretty stable, right? Like there's that one instance in the 6.5-year history of OpenTelemetry where it sort of made major specification upheaval. The SDKs are idiomatic to the source language. This can be a pro or a con, right? If you're a Java developer, you're very familiar with Java idioms and Java ways of doing things. And the OpenTelemetry project very much tries to adhere to that within each of the 11 languages that it supports. It also means there isn't really like an OpenTelemetry idiomatic way to do things. So like if you're just an SRE team trying to instrument a bunch of services that were lobbed over the wall to you from your dev teams, and you are not expertise in the languages that they were using, this can be kind of a pain. Probably what you should be doing in that case, actually, is making the dev teams, right, like learn this stuff and instrument their own stuff. But that's a topic for a whole lot. Duplicate data can confuse tools, right? Don't instrument the same service with 2 different technologies. Just don't do it. In general, don't install 2 different node agents on the same node. There are ways that you can make it work, but I've never seen it actually work. And you can really confuse the backend tools, right? Like this is actually a whole new can of worms that OpenTelemetry opens up because the vendors used to have complete control over the provenance of the data. They knew exactly where it came from and how it was processed along the way to them. Now they don't. Now you can send them whatever you want. Now you can send them metrics for a Kubernetes pod and tell them it's a VM through the metadata, and their backend is going to be like, yep, that's a VM. So, yeah, this is a brave new world. And then, okay, technically speaking, right, specifically with metrics, the way that most of the OpenTelemetry ecosystem tools are built is with a preference for extreme cardinality, right? Like everything is a label. And there's sometimes, right, like depending on what system you're using to store this, you might be actually paying a lot of money for labels that you don't need unless you're using something that was specifically designed to handle this kind of cardinality. And then low granularity. So when I say low granularity on time series, I mean like multiples of 15 seconds, right? So 15, 30, maybe a minute granularity in terms of how often you're scraping the metrics and updating. Versus other tools which might be on the order of like 5, 3, 1 second, right? That's just a thing that you're going to have to keep in mind with your storage engines, the way that you structure your metadata, and the way that you structure your queries. It doesn't mean you're stuck with this, right? You don't have to use OpenTelemetry metrics with OpenTelemetry tracing. You could use the tracing, use Prometheus metrics, and that's another cool thing about this project. Like, holy cow, how rare is it in the entire industry that we do that we have compaction of formats instead of expansion of formats, right? Like everyone knows the XKCD script. Now we have 15 convening formats. I don't even put it on here because it's so popular. But it's like, OpenTelemetry is actually an example of us reducing that number. That's awesome. And like Prometheus, it's been so effective that even the Prometheus project, which has been the de facto standard for metrics for as long as I've been in the field, like they're co-evolving with OpenTelemetry. They're like, okay, OpenTelemetry is the new way. We need to be at least compatible with it, if not participating in it. So that's really, really powerful and really cool. Okay, and then the last pitfall and warning is that there's a lack of examples. That's just categorically not true anymore. There's this awesome project called the OpenTelemetry Demo Project. So this is the GitHub URL. Note that there is a hyphen in the GitHub organization name. That's the only time you'll ever see a space or a hyphen in OpenTelemetry, and it's correct. Everywhere else it's like this, with no space or hyphen, and that's also how it's referred to, like everywhere publicly.
You meant
this project is awesome. It gives you this telescope shop, kind of based on like the hipster shop Google project, if you're familiar with that. But it's an astronomy store. So this, right, because the OpenTelemetry logo is a telescope, it's the telescope store. Very fun. So it's a Node.js front end. It's a very, very contrived backend, right? The goal of the backend is not to be efficient or well designed. The goal of the backend is to demonstrate every language and feature that is supported by OpenTelemetry. So if you kind of think about how you would design a backend with that goal in mind, that's how you end up with 18 different microservices to power a store that has 3 products. But you get some really, really cool stuff with it, right? It's a bunch of built-in monitoring. So here's a different example of that RET metrics dashboard that we were looking at, like at the very beginning of the talk. This is actual live data, right, coming out of the OpenTelemetry demo project. You can see some of those 18 microservices that I was talking about. And we can start to see the latency across all of them. So you can just spin this up. You can just pull this down right now, run Docker Compose up, and in a few seconds you'll see this. It has built-in Jaeger. So this is a tool called Jaeger, which is used for visualizing traces. Great tool for like development environments, pre-prod environments. Yeah, so here we can visualize some of the traces coming from the OpenTelemetry demo project. This is the trace coming from the product catalog service. So this is right. Some of that I mentioned that you can have like all of this high cardinality dimensions on the traces. So these are some of them. There's a product that might be really high cardinality at some workstations. This store is obviously not. It's like 6 cell stores. Right, IP addresses. Those are insanely high cardinality. We can just throw that in there. We put it under the app key if it's something specific to our app. That's just a convention. And how do we get this in here? Really easy. This time you can go, not Node.js, but it's the same thing, right? Get it to context, apply the tag. So this is not rocket science, right? It's just a tag. But it's also not complete, right? What I've been showing you is not a complete solution. It's not going to solve all of your observability and monitoring woes. You need like more, right? So we've been talking about how OpenTelemetry can kind of cover a lot of stuff on the left side of that graph, right? It's got your application SDKs covered. It's got your host and node agents covered. In most cases, it's got collection, sampling, and processing covered. And you can either use the OpenTelemetry provided tools, or right, like you can use any of them, any vendor provided tools that are compatible with it. I've talked to people who are getting all of their telemetry from any source into a Kafka stream. And then that would be that middle box, right? It's just your Kafka stream of all of your observability data. Then you're going to ship all of that off somewhere to be stored, right? Some database or some collection of databases. And like we mentioned, there might be some kind of gateway, because if your storage technology doesn't like to have a lot of open connections, you're going to create some kind of gateway or proxy that manages those connections. That might also be an instance of the OpenTelemetry collector. So OpenTelemetry is like moving farther and farther right on this graph, right? And 3 years ago when I first gave that talk, like no one was really talking about the OpenTelemetry collector. It was all about the SDKs and node agents. It's just getting closer and closer to those vendors, right? But okay, that's all really cool. Finally, we need like the analysis UI and alerting. The de facto open source ones for this would be Grafana and Alert Manager. Tons of vendor-based ones that are really good. There's also some other really exciting technologies. They're not under OpenTelemetry, but are kind of in the familiar ecosystem. So eBPF is one of them. This is actually used in the OpenTelemetry Go auto instrumentation. I didn't mention that one of the languages to do auto instrumentation for, because it's compiled. How do you do auto instrumentation for a compiled language, where we've discarded all of the human readable context by the time we have the binary running on our machine? Well, eBPF gives us a way to observe compiled binaries. Right now it works pretty well for Go. There's work underway to make it work for some of the other compiled languages, but for Go it's pretty strong. And basically, raise your hand if you're not familiar with eBPF. Okay, for those folks, thank you for your honesty. It's a tool that's built into the Linux kernel. I think it's been around since like 2017, 2016. It is originally designed for network security applications. So for example, WireGuard leverages this heavily. But basically what it does is it lets you add hooks to syscalls. And it does it in a way that is safe. So it doesn't let you write all of C, it gives you a subset of C that it can guarantee is safe. So it can give you things like guarantees that the program will halt and things like that you couldn't actually do with a Turing complete language. So it gives you this subset of C that you can do really, really useful stuff with, just hooked into the kernel space of another process from your own user space. Yeah, wow. So it empowers a ton of things, security focus, but observability also. This is a tool that uses eBPF and OpenTelemetry. It's called Kuru. So this is like a batteries included open source observability tool. You can just install this again. So for this screenshot here, actually all that I did is I pulled down the OpenTelemetry demo project and I typed in Docker Compose up, and I pulled down Kuru and I typed in Docker Compose up. That's it. No extra work to instrument anything. Now the OpenTelemetry demo project does have all the instrumentation built in, but that's not what's coming through here. This is coming through from eBPF. If I wanted to send that OTel data and also enrich it with all that extra metadata that's in those OTel attributes, I can send that here, and code group is smart enough to merge it all together. But until I've done that, I still get my complete topology, I still get my complete map of everything talking to everything else through the power of eBPF, through actually tracing the syscalls to the networking stack on Linux boxes that these services are running on. And then code group, right, I just love it because it's like, you install it and you immediately get value out of it. It's not going to go as deep as some other more mature observability platforms, but it's just like, just turn it on and see what you get. It's really, really cool. I'm going to wrap things up and we're going to have some time for some questions. So my closing thoughts, why do we care? Right, why open source observability? I kind of opened with this, but we'll reiterate, right? It's vendor neutral instrumentation. This is what empowers people to include the instrumentation in their things that they're then sharing with the world. That's why vendor neutral instrumentation was so important. Even if you're still ultimately sending the telemetry to a vendor, right? This is just a really big change in the ecosystem in terms of how the software gets made. Then we have the portable telemetry formats, right? OTLP, my favorite part of OpenTelemetry, which enables this whole ecosystem to function and enables everything to talk to everything else all the time, not just on that fateful day where you're like, oh, we're switching from Datadog to Dynatrace. Right? No, it's just all the time, everything's interrupted. Right? And so yeah, vendor neutral instrumentation combined with portable telemetry formats powers these interoperable tool chains that are just beautiful, right? It gives us the ability to mix and match and use whatever works best for our situation. And it's all also all open source, which means we get to all learn and grow together. If someone makes a modification to the auto instrumentation for a library, you get to benefit from that, right? We're not all chasing the same dragons. We get to work together. And I think that's beautiful, I think that's awesome. And that's all I've got. Time for questions. Yes.
What is the susceptibility to log tampering attacks for OpenTelemetry? Because this is something we...
Oh, that's not something I thought about before, like, articulately. Can you tell I don't come from security, I come from observability. Yeah. And usually I think observability and security people hate each other, like, the most. Right? So, yeah, no, it's a brave new world, right? Like, before that would have been a question for your vendor. And they would have to tell you what protocols they're using for the communication, right, and how they're approaching it. Yeah, I don't know. I think it's probably an area that needs more exploration. And if you want to come into the OpenTelemetry community and like tell us how to do it better, please do. Yeah. Any other questions? Okay, I answered them all. Great. I have some stickers if you're prone to talking about, I have a few stickers if you're prone to talking about open source.